Hey everyone, thanks for coming. I'm going to get started with the presentation, and if you have any questions, just drop them in the chat. So today we're going to go over what sklearn is, why it's useful, and how to use machine learning models in general. Then we'll do a quick demo using a linear regression model and a k-nearest neighbors classifier. So what is sklearn? Scikit-Learn is an open source Python library that's used for applying machine learning models to data. It has a lot of capabilities, which I'll go over in the next couple of slides. This website right here is the Scikit-Learn website and contains all the documentation for its machine learning models and also includes helpful examples as well. So Scikit-Learn is useful in a lot of different ways, but they usually fall under these three umbrella terms: data preprocessing, data modeling, and model fine-tuning and pipelines. So let's look at a few specific capabilities of Scikit-Learn. Within data preprocessing, Scikit-Learn has many types of scalars, such as min-max scalar, standard scalar, robust scalar, etc. Data preprocessing capabilities also include data filtering, such as dimensionality reduction and feature extraction, as well as helpful features like imputation, one-hot encoding, discretization, and column transformers that will help clean up your data and get it ready for you to train your machine learning models on. There are a lot of different machine learning models available to you once the data has been pre-processed, but the type of model that you choose depends on what kind of task that you want, the kind of task that you want to perform. If you want to perform a regression task, you could use a linear regression, polynomial regression, nonlinear regression, or gradient descent, to name a few. On the other hand, if you wanted to perform a classification task, you might want to use logistic regression, k-nearest neighbors, or naive Bayes. Machine learning models like decision tree and random forest are models that can do both regression and classification tasks. Other machine learning models that you could use are NLP clustering algorithms such as k-means and many others. Once you've decided on which machine learning algorithm you want to use, you'll probably want to fine-tune your model parameters so that you can create the best performing model that you can. sklearn features regularization, validation, and cross-validation, and grid search as some of the things that you can do to improve and fine-tune your model and model parameters. The fourth feature that Scikit-Learn provides is the ability to use a pipeline to chain multiple commands into one. For example, if you have 3 different pre-processing steps, you can do it in one command if you define it in a pipeline first. And I'll provide an example of that later on. Are there any questions before I start explaining how to implement machine learning models? All right. So now I'll go over a general overview of how to use machine learning models. So we can practice this later in the demo as well. So the first step before you fit the model is to pre-process the data. This step is really important because you can check for which features are most important / most correlated with the target variable and filter out features that aren't important. You can also scale the feature matrix as needed because scaling helps prevent biases in the model, and imputers can help handle missing data. Overall, all of these pre-processing steps can help clean up your data and help your model perform better. So just as an example, say we wanted to use the standard scalar on our data. From sklearn preprocessing module, we would import the standard scalar, then name our standard scalar like this. Once we have the scalar, we can scale the feature data by using dot transform. Transform is typically used before the data is split into test and train groups, which I will go over in the next slide. So splitting your data set into testing and training groups is really important. The training data will be used to train the model and learn the model parameters that would best enable it to make predictions. And the test data set will allow us to test the model's predictions and look at its accuracy and other evaluation metrics. So the first thing we have to do is split the data into a feature matrix and target variables. So you can think of the feature matrix as the X variable and the target variable as the Y variable. So here in this example, I've stored the feature data frame in the X variable and the target values in Y. So then we can split up these data into train and test groups by using Scikit-Learn's functionality train test split. So from Scikit-Learn model selection, you can import train test split and split the data with a test size of 0.2. This test size indicates what percentage of the data I want to save for testing the model. So here I use 0.2, which means 20% of the data will be 20% of the total data will be saved later for testing. Once you have your preprocessed data set split into training and testing groups, you can fit a model to your data. Like I mentioned before, Scikit-Learn has a lot of useful machine learning models that you can use. So check out the Scikit-Learn website if you want to see more. Here I have an example of a decision tree classifier. So first from the Scikit-Learn tree module, we'll import the decision tree classifier and assign it to a variable name, then fit it on a training data set. Next, after the model has been trained on the data, it's ready to make predictions. So you can predict the target value based on the number of features by using the predict method. So for example, if we named our classifier CLF, which we did in the previous slide, we would use clf.predict to make the predictions for the test data set. We can also test the accuracy of our predictions using the .score method. Yeah, it's really helpful to score the model's accuracy for both the test and training data sets. Just to iterate, the model is trained on the training data and tested and evaluated on the test data set. So if the model learns the training data too well and it isn't able to accurately predict the instances that don't show up in the training data set. This is called overfitting, and a good way to check for overfitting is to look at the accuracy of the training predictions versus the accuracy of the test data predictions. If the accuracy of the training data is much higher, that's an indicator that the model is overfitted. There are a lot of ways to solve overfitting in a model, such as including regularization terms, cross-validation, early stopping, and a lot of other functionalities that are included in Scikit-Learn. So here's an example of a pipeline from the pipeline module. You would import pipeline, and in this example, we're chaining together a standard scalar and a linear regression model. if you're building your own pipeline, you can chain together even more preprocessors. Once you've made your pipeline, you can call pipeline.fit to fit the model on your preprocessed training data set, and then use that model to make predictions for the test data set. If your pipeline only includes preprocessing steps, you can call pipeline fit transform to learn the parameters of the data and transform it as well. These pipelines are useful because they allow you to create a really convenient workflow. So next, I'm going to do the Scikit-Learn demo. Are there any questions? Does anyone have any questions? Do any of the models have inbuilt pre-processing? No, you would have to do the pre-processing with other preprocessors. So I can go back to that slide. Yeah, so just like a few examples of preprocessors, like you can use like scalars, you can use encoders, like even discretizers, but the machine learning models wouldn't have inbuilt pre-processing.
Hi, I just had a question. So do any of the models, like even something as simple as a min-max scalar, is it possible for it to be inbuilt? Or suppose I do pass a dataset that is not pre-processed to a model, will it still function, or will I get some sort of an error?
Sorry, so the model is like the models wouldn't have like inbuilt pre-processing.
Oh, okay. So if I did pass a dataset without pre-processing it to a model, would it give me an error, or would it still function but give me some random value of a—
Yeah, it would still function, but I think like the presence of like NA values, for example, or maybe like the data not being scaled might have an impact on the model because it would introduce biases or things like that. Yeah.
Okay, thank you.
Mm-hmm. Okay, so for the Scikit-Learn demo, so usually we don't import the entire Scikit-Learn library, but like importing the whole library isn't the optimal way to do it. So you would usually import a specific module in the Scikit-Learn library. But yeah, before this demo, I guess like make sure you have Scikit-Learn installed, and you can check the version of Scikit-Learn that you have. If you don't have Scikit-Learn installed, you can install it using pip, like pip install Scikit-Learn, and just put that in like in command line. So I'm going to share my Jupyter notebook. Okay. Great. So here I'm just importing Scikit-Learn just as an example, and checking the version. When you put in the version, you should see something like this. So first, we're going to do a linear regression example with the diabetes data set. So first, we're going to load all of the necessary libraries that we need. So importing pandas just for data frame manipulation. and NumPy for vectorized operations. And then with all these, and then we'll import a bunch of these scikit-learn modules. Yeah. And then matplotlib to visualize our results. So the first thing we have to do is load in the data set. So we're using the diabetes data set, which is included in scikit-learn. And it puts the feature matrix, it separates like the feature matrix from the target variable. So X is going to be the feature matrix and Y will contain the target values. So we can take a look at the data frame. Just a quick look here. So here's the head of the feature matrix. We can see that it has 10 columns. And the Y variable has just one column with like it's a continuous variable. So yeah, and it represents weight. So what we're going to do is try to create a linear regression model that can predict weight based on BMI. So first, pre-processing, just we need to extract just the BMI feature. So we'll take column 2 and print that. So now that we have just the BMI feature in the X variable and the target in the Y variable, we can go ahead and split the data into train and test groups with a test size of 0.2. So again, 20% of the data will be used as test data. Then we can go ahead and use a linear regression model. So this linear regression model is from the Scikit-Learn linear model module. And we're going to name it linreg. So once we have this model, we can fit it to the training data set, which is X-train and Y-train. And once that has been trained, we can make these predictions. So I've put predictions for the test data as well as the training data. And here's just an example of like what the prediction would output. So this, you can see that it's outputting like something, it's outputting numbers that would represent predictions for weight based on the BMI in the X in the features data frame. So the next step would be to evaluate the model. So one thing we can do is use the explained variance score, which is basically like the R² value of the linear regression line. So here it says that the R² value or explained variance score is 0.33 about. So this means that only about 33% of the variance is explained by the model. So yeah, and then we can also evaluate the model using mean squared error, or MSE. And so I compared the mean squared error of the test, the actual Y test values against the predicted Y test values, and the same for the training data. So the MSE is higher for the training data than it is for the test data. So given this information and the relatively low R² value, we can probably conclude that linear regression might not be the best model for this data because this model doesn't capture enough variance, and it needs a more complex model to capture all the variance and output accurate predictions. And this is just a visualization of the linear model. So here we've plotted the test data, and here are the predictions for Y test. Are there any questions? Okay.
So
So
sorry.
yeah, go ahead.
So we concluded that the linear model is not good. So are we trying a new model now?
No, that was just like one example. We can definitely like try other models, but yeah, for now, just like for this example, I mean, this is like a new data set, a new example.
Okay, so we start brand new data set and brand new model. Okay.
Yeah, yeah. Okay, so this is the k nearest neighbors example with the iris data set. So a different data set. Yeah, so right here, we're just importing the necessary libraries. Yeah, so the iris data set is also included in the Scikit-Learn datasets module. So all we have to do is load this data and then get two particular values, the sepal length and width from the data, and then our y variable. So that'll make up the features data frame, and then the y variable will be the target values, which is the classification of flowers. So here, if we look at the data frames, you can see the sepal length and sepal width for each flower. And then you have the Y data frame, which is really like a class. So it's 0, 1, or 2. And those values correspond to like the classification of flower that they are. So with this k nearest neighbors example, we're going to use both sepal length and sepal width to predict the class of flower. So with data pre-processing, we can try doing a standard scalar. So this scalar, we will use fit transform on X, and that will transform the data and we'll save it to X scaled. So this standard scalar actually scales it on a normal distribution. So then after we have this scaled data, we can split the data into training and testing groups. So using the scaled features data frame. And yeah, and the test size is 0.2, which is 20% like before. So now we have the k nearest neighbors classifier model. I've set the number of, so k nearest neighbors really, so with a data frame, if you think about data points on an X and Y plane, you can think of it like doing a majority vote of the nearest of the data points that are closest to the input data point. So when you specify the number of neighbors, this n neighbors specifies just how many closest data points to look at. And that, so this k neighbors classifier, we'll save it to k on n, and then we can fit it to the training data set. So then we can evaluate the model by accuracy. So this score method is going to, it just scores for accuracy. So you can see that the test data scores 80%, and then the training data, it scores 83%. And yeah, so this is just a visualization of what it's, or how it's deciding based on like decision boundaries. So this is the training data. And these decision boundaries kind of indicate where it would draw the line between like based on what the training data are. So so this is like after the model has trained, and once it gets new data based on this kind of map, it'll decide what to classify the input. So like if a new data point ends up somewhere here in the blue region, it would classify it as a Virginica. And yeah, so this we can do the same thing with this data. So this is the same iris data set with the same columns and everything, but we can do the same thing in a pipeline, so it's more streamlined. So you can see you have the standard scalar over here, and then the k neighbors classifier as well in the pipeline. And all we have to do is call pipeline fit on the training data and then predict. So this is an example of what it's predicting. It's predicting like the classes of each flower. And then we can print the score as well. So it's just doing the same thing, but in a pipeline, using a pipeline.